And now we'll continue with the Pragmatic GraphQL Patterns with Richard Shan. So Richard, are you able to join us?
Yeah, I'm here. Can you guys hear
Hello,
me?
Richard and Anthony, right?
Hey, can you hear me?
Perfect. So yeah, we can hear you. Actually, we hear you, but with a low volume. I don't know if you're far from the microphone or.
Well, maybe I need to speak louder.
Yeah,
Yeah.
maybe.
Okay.
Perfect. Thank you, Richard.
All right. Thank you, Mehdi. Thank you for the introduction. Hey, good evening, good morning, good afternoon, depending where you are. Thank you for joining this session. Today we're going to talk about the GraphQL patterns. So this is a list of the topics we're going to hit today. We start with some fundamentals about the GraphQL. We look at the current state, look at some of the challenges and the barriers we have today. Then we introduce a pattern approach. From there, we drill down a specific module in the pattern model. Then we talk about some of the guidelines and best practices. So let's start with what is GraphQL? If you were in the last session, probably I can skip it very quick, right? The big difference for this one, maybe I'll show you this difference, right? On the left side, that is the traditional way we write a SQL query, right? We look up some fields from a table. On the right side, you can see it's much simpler. You specify a particular entity, then you put the attributes what you need. Why do we use GraphQL? Obviously, I think last session, the presenter also talked about some of the benefits. Essentially, it reduces complexity. And also the schema helps to check, what kind of elements, what kind of type. No overfetching or underfetching. This is critical, right? A lot of REST APIs, you have to live with what is described or prescribed. You cannot change here. You can selectively say, hey, give me part of it, right? And which saves time and the network bandwidth. There's some other advanced features that really, the traditional REST API does not provide. So in the diagram, you can see it's, with the REST API on the left side, it is a little bit, complex. On the right side, it's much simpler. You have the one endpoint. Then obviously the handler you need to implement, but, in terms of the client interaction, it's much simpler. Now let's take a look at the current state of the art. This is the literary extract from the State of GraphQL report published last year. So one thing is the usage. You can see almost half of the developers are using GraphQL to exposing some APIs for personal website or applications. 40% of them are using GraphQL for internal usage. Then in terms of client, 62% are from the browser. Next, we look at the sort of like a backend. 55% of the GraphQL APIs actually hit the databases, while 35% are using the existing REST APIs. And predominantly, GraphQL used in programming. Literally, you have these professionals, doing some coding and provide some resolvers and all these kind of logic, enable these GraphQL. And then break down into some other sectors with the numbers here. So with that, what kind of challenges we have? Again, this is from the State of GraphQL report, and you can see it lists some kind of a top headaches, right? Error handling, how does it perform well or scale well? What about the client-side caching to do it? Security, of course, versioning, file upload, and some other pieces. So with that, you can see, it is not overly complex, but, there are a lot of, I would say, obstacles that as a team, as a developer or architect, we have to address these concerns. So we advocate a pattern approach. Now, what is a pattern? In the IT world, a pattern is a reusable solution to a common problem. In other words, this kind of issues have been recurring in different contexts, but they have sort of like common characteristics. So we can try to, leverage some best practices to tackle them in a systematic fashion. Just to let you know, pattern is not a solution or product you can just, deliver. Rather, it's sort of like a template which helps you to speed up or address the what kind of concerns, what kind of issues in a more programmatic fashion. So a good example is a book, 23 Design Patterns by Gannett Ford. So if we count today, it's almost 30 years. That's a seminal work, these 4 gentlemen did. Now, what do we need patterns? It has a lot of benefits, highlight some of these things here. Obviously, it provides the flexibility in design, and also it separates the duties, enhance the scalability, performance, and reusability. In particular, communication and collaboration, because if you use pattern, we literally use a very similar set of vocabularies to communicate, rather than somebody talking these things and we talk about this one, and it's kind of like gaps in terms of communications. Now, in the GraphQL world, there are a lot of patterns, a lot of things that I would say evolve from old microservices, REST APIs, and even legacy application development, right? So we try to kind of group them in some classification. Specifically, you can see we modularize these into framework, architecture, construct, execution, topology, and schema. So this helps us to literally sort them out and group them together. And in this particular session, we're going to drill down to architecture patterns. So in particular, we'll talk about these 5 patterns: database interface, system proxy, composite service, single endpoint, and native API. So the first one is database interface. So if you look at this diagram on the left side, we literally talking about the client. In other words, whoever is going to launch a request, whether create some data or create an object. You can look at this sort of like, the request from client side. Then this request is hitting a database, which has, tables, system records to, take the request, create a new records, or search for a particular, field for some, let's see, look up the email for my name, right? That type of thing. So what we put here is GraphQL server, which is actually typically bundled with a web server. So from client side, they just talk to a particular endpoint. They don't need to know the details. Everything is handled here in terms of process the request, then resolve the request, then in turn make the CRUD call, CRUD call to the database. Then typically when this come back, it is a result sets, right? And you have to pass this one and maybe paginize that and send it back to it. So this handles everything over here in the middle. In the next pattern, we know in the corporate world, we have a lot of existing applications, whether these are legacy systems, maybe even mainframe, kind of like systems there. And we have microservices. Some of these may be monolithic. And maybe, you consume some cloud API like Salesforce, right? So it's a combination of this one. So for the client side, we don't want to talk to this, kind of like a point-to-point. That's difficult, right? Rather, we have the SQL server here. The client keep talking with the way that, designed for GraphQL query or creation. Then this one is literally say, pass that request. Then, with this individual, it can, retrieve the data or send a request or even, do some asynchronous way. So this literally over here provide a proxy to existing applications or services. Next one is called a composite service. As you can see the diagram, we literally have these two combined, right? This what these services you see in the last pattern, and this is the first pattern. So here we literally have this one to kind of combine these. So it can be passed through, which means, if this individual database hit, go from this route. And if you want to consume mainframe, RCRF lookup DB2, and you get this one. On top of that, this can aggregate these things because you send a request and the data elements may not write in one place and rather different places. So this can literally invoke individual services and aggregate the results and send it back. Now the next pattern is called a single endpoint. Now we look at the right side. This is exactly the same as last pattern, but these are kind of like for internal, because if you want to say, hey, here's a client request coming here, how do I authenticate this client? How do I entitle this client to, oh, you want to call mainframe, or you want to call my SQL database, or what have you, right? So there's some control needed, particularly from security perspective. So this here we introduce the API gateway. This really provides a single endpoint. When the request coming, it authenticate, it entitle it, it even kind of meet it, sorting it, and with different kind of monitoring capabilities. Now further to that, one single API endpoint is not enough for the GraphQL capabilities. So specifically in GraphQL, we have queries, we have mutations, we have subscriptions. So in that case, you only have one endpoint, it will not fit well. So this is sort of from very simple single endpoint to break down into different groups. And also in terms of the subscriptions, you cannot do the traditional kind of like we call the request response blocking call, because subscription actually is event driven. So you need some asynchronous way to do that. And from that perspective, the last pattern is only applied to some simple use cases. And we really need these kind of like different endpoints, but not as many as previous, the pattern number 3, but group them in similar fashion, and then provide the even some discovery capabilities, cataloging, API management, and governance over here. Now we talk about these 5 patterns. Now the next thing is how we can use them, right? So in this chart, we list some pros and cons for each of these we discussed. So the first one, it's very simple to implement. So if you start from scratch to build some GraphQL capabilities, this is the way to go. On the other hand, it is tied with a particular database, depending on what you use, and you have to look at whether it's a connector to the database, or you build your own resolvers, things like that. Second pattern, the good thing is, existing systems, applications, you literally can reuse them, right? The people don't need to know how do I interact with them, what is the port, all these things, right? So no change to the existing services. You can, maximize the reusability of existing applications. On the other hand, whatever the constraints in the existing system, you cannot change it, because that's the naturally that's what it can provide. And also, if you want to add some new sources, like new data source, new stream, it cannot do it. Certainly, this one is composite, right? So the good thing is kind of like the best combo, right? Leverage the best of the first one and second one. And secondly, this is the path to increment the sort of migration, because some of the existing system you want to refactor it, you want to re-architect it, then it takes time, right? Rather than wait for a year for us to move all these things, you can say some of these let's expose this one, let's hide the complexity. So that's the benefits for very fast migration of older services. On the other hand, barriers of the existing system, that's similar to case number 2, and also the complexity. When you want to do some aggregation of these things, and sometimes, because of the incompatibility of the different data elements, it will create, I would say, challenges to us. Now, the first one, we just say, okay, yeah, rather than expose all these GraphQL APIs, hey, we want to manage some security, entitlements, the authentication part, right? And also you can meet it, you can sort it, and you can monitor the consumption and whatever, maybe setting different tiers if you want. And the downside is more complex since you add the API gateway, and also cost of it, skill set, you need to maintain that. The last one is the native API, as we mentioned. The good thing is literally provided all these GraphQL capabilities, like queries, mutation, subscriptions, to the consumer side or the client side. And it generated the specific endpoints for the consumption. On the other hand, the complexity is the max, right, among these 5 patterns. And also, if you want to implement the subscription feature, need a multi-steps. It's not straightforward. Hey, go to API gateway. Let's implement. So on the right side, there's some examples listed over here, which shows you, hey, for this specific pattern, you can leverage some open source products or some vendor commercial out-of-shelf services to implement these patterns. So next one is, we kind of understand the pros and the cons, right? But still, you want to see how do we select, right? So this is really up to the scope of the project. Over here, I just show you the very simplified version, right? For example, if we start from scratch, it's a greenfield project. Database interface is probably the most viable thing to do. And if you start with brownfield with a lot of existing assets, services, APIs, applications, then use system proxy makes most sense. Then if it's a hybrid mode, let's break down if it's internal use inside of your team or inside of your group. Not too many controls you need to apply, then use Composite service. On the other hand, if you have some partner usage, you really want to apply some entitlements, control, API governance, and you probably single endpoint is the best fit. And the last but not least, if you're doing some customer facing and you want to use the native API pattern to fit the bill. So next is about how do we apply this. Now this is kind of extract a little bit. We talk about this particular architecture patterns, right? That's just one part, because we look at the GraphQL application or service development, it's a life cycle. I kind of simplify with 6 stages: discover, define, design, develop, deploy, and deliver. So each category or each stage we build patterns. That's actually, as I mentioned earlier. Then, in general, some guidelines, right? How do you apply these patterns effectively? You need to define these data types very well, structure. It's ideal to decouple front end from the back end so you can separately do this. Create a schema to define APIs, use tools to validate their schema, and leverage tools to kind of like generate the kind of code automatically once your schema defined. So the client side do not need to do it from scratch. Test it well, query the relevant object in one single call. But even though I know, right, GraphQL is much more efficient, avoiding overfetching, but you still sometimes you want to say, let me combine these things to, rather than chatty talk to the server side, and also use a pipeline to automate the deployment, handling the error consistently, and manage permission. So some of the best practices. Understand the problem well, and this I think is very general, right, for different types of applications. So I put some kind of like a checklist of what kind of question you should ask. You should drill down to kind of like fully understand what exactly the problem we're dealing with, what kind of the hidden things, what kind of assumptions, what kind of dependencies. Second one is take the best approach. As we talk about the patterns, there are a lot of these, right? And not necessarily one is the best. So a lot of times you actually have to do the trade-off, right? Hey, let's compare these, and how do we weigh different benefits as well as the cons, and figure out what's the best approach to do it. Then plan out the ownership. Because as you look at the GraphQL, it's a multi-party. There are a lot of things, client side, backend side, database side, API gateway side, And really, you want to create a racy chart. So everybody will be on the same issue. Who is accountable for that? Who is going to implement that? Who is going to verify that and all these things. And the last but not least, GraphQL is not a silver bullet. We don't expect that this will solve all these, integration issues, right? But, when you apply this one, look at, what kind of values it add, focus on low-hanging fruits, get something built out. Then, it can evolve, right? To see, build on top of that, what do we need to do? And a quick recap over here, we talk about the fundamentals, look at the current state, we talk about the obstacles we have, and then we advocate, taking pattern approach, we drill down to architecture patterns, we discuss briefly about some guidelines, and last but not least, we kind of elaborate some of the best practices. With that, I want to hand it back to Maddie for some questions.
Hi, Richard. Thank you very much for this presentation. A quick question about the different patterns that you present. It seems some patterns are a real fit for GraphQL, and from what I understood, some patterns are kind of adaptation of GraphQL to this pattern, right? Or do you recommend all these patterns to be fully effective with GraphQL technology?
Yeah, I think it's a mix. Great question. So the patterns here, we call it dependent libraries. And it has a mix of the patterns that kind of evolve from the old microservices, REST API development, or enterprise integration. But they are kind of like a little bit modified to adapt it to the GraphQL domain because, there are different contexts. And there's another set of patterns that are very new or native to the GraphQL that do not, exist, those problems or issues in the traditional way. For example, schema, right? Resolver, that type of thing, or schema stitching. Those kind of patterns, they don't exist in the previous world. So we have a mix of this one combined together.
Yeah, okay. Interesting aspect. Also about the adoption of these patterns. Do you see any pattern today which have more adoption than the others, or that is easier to adopt by starting companies with GraphQL? Yeah,
in terms of adoption, I think I shared the state of GraphQL report, which published every year. I put on the last year because the latest had not been updated. So from that one, it's kind of provided the kind of like survey how people feel about it, and I can clearly see because this report has been, I think it's more than 5 years, right? The gradual growth, the steady growth of adoption of GraphQL. In the meantime, a lot of new challenges as people working on this one. So I would see, from good side, the adoption rate is there. I think a little bit accelerating. And also people are more and more leaning to using this one to see the benefits, right? Rather than the old way with the monolithic API, with the microservices that's, too heavy. And the REST API is light, but, it is, chatty, you cannot change, that type of thing. So I think it is there. On the other hand, I think, another big challenge area, I think, is for community, as, really like this forum, right? To advocate the usage of the patterns, advocate to literally to speed up the learning curve, right? For the teams. So they struggle on this one, then if you use pattern, it will save their time rather than understand like, introspection. How can we use it? Where do we use it, right? That type of thing. That's what we advocate, using patterns to shorten the learning curve and speed up the adoption in a faster way.
Perfect, Richard. Thank you very much. We reached the time allocated for your talk. Thank you very much for this presentation and actually describing all these patterns in a way that are that really explain the difference and which fit for which use case.
Thank you.
Thank you for that.